Hello everyone, today we'll talk about the problem hand of straights. We're given a list of numbers and a group size, and we want to separate those numbers into groups of size, group size, such that every number is used exactly once, and each group, when sorted, consists of consecutive numbers. So I plus 1, I plus 2, and so on. So for instance, 1, 2, 3 is okay, 6, 7, 8 is okay, but there can be no duplicates and no skips. Now, the problem doesn't ask us to create the split, just to say if it's possible, but we'll probably create the split along the way in our solution. Now, how to approach this problem? Well, imagine that we have those numbers, let's say 1, 2, 3, and 4, for ease of thinking. And of course we can split it. We can split it into 1, 2, and 3, 4. That's pretty obvious. And perhaps we can create a solution that just takes, for instance, one number, takes 1, creates a group with it, gets 1, 2, and that's okay. Then does the same with 3, 4, and gives us a correct solution. And of course we have to watch out that we do not ever try to create a group 2, 3. Because if we create that group 2, 3, then there is nothing else we can do with 1 and 4, and then we'll return that it's impossible, while it's possible to split these 4 numbers into groups of 2. So in other words, if we're able to always, when we start to create a group, determine that our start position is okay, then we'll solve this problem. By the way, we also have to make sure, for instance, if we start to create a group starting at the number 7, that we do not traverse the whole original array in order to create that group. We have to do something faster. And if we can create a group in time proportional not to the length of the original array, but to the group size, then this will be okay, because we will in time proportional to group size create a group of size group size, and the total number of sizes of all groups can be at most the number of numbers in the original array. So this will still be linear. You will probably have some nested loops, but those nested loops amortize to just be of linear time. So that's also something that you should keep in mind. And so the idea now is just to be able to tell what number certainly can be taken as a start of some group. Probably the most obvious solution here is always to take the smallest number. That's because if an answer exists, the smallest number has to be in some group in that answer, and that smallest number has to be the smallest number in its own group, because otherwise there would be a smaller number in its group, but of course there is no smallest number. So we can always start with the smallest number. And on the left you have an example implementation of just sorting the numbers and implementing that. And we'll be doing that by first sorting the numbers, then converting the numbers into a compressed representation. So instead of 1, 2, 3, 4, we will have that we have a single 1, a single 2, a single 3, a single 4. So all the numbers will be pairs of value count. That will be useful because then we will not have to traverse the whole array. For instance, if we have group size of 2 and we have like 1,000 ones and then 1,000 twos, it's possible to split them, but for the first one, we will not have to go through all the other ones to reach the first two. Instead, we'll have something like 1, 1,000, 2, 1,000, and this will be the compressed representation. Right? And in that case, of course, in the compressed representation, we can always start with the leftmost number that is not of count 0. We'll, of course, while creating our groups, reduce the count of all the numbers that we use. So we can just go from the left through all the pairs of numbers and skip all the zeros. And as soon as we find something that appears a positive number of times, then it has to be the smallest number in exactly that many groups. So we have to go through the next k pairs, reduce the count of all those numbers by k, and of course those numbers have to be exactly the second. So for instance, if we start at 1, the next number has to be 2, then 3, then 4, and so on. And of course you can look at the specifics here. So this solution will sort the numbers, represent them in this compressed form, in which case we are guaranteed that because this is the loop that goes through all the different numbers, different values, this is that internal loop that goes through the group, and this guarantees us that this internal loop goes in time proportional to the group size, which is k in my case, and not proportional to the number of numbers in the original array. That's why we use this compressed representation. So you can look for the specifics on the left. And I'll also show you another solution, which is based on, let's say, a generalization of the observation that we made previously, because our previous observation is okay, that we can always start with the smallest number. And why can we start with the smallest number? Well, because there is no number before it. There is no number immediately before it, and it will be necessary to have that number immediately before if this number was not to be the smallest number in its group. But in that case, 1 might not be the only possible value for such a number. And for instance, in this first example, we see the number 6. And that number 6 knows that there is no 5 before it. And since there is no 5 before a 6, then the 6 has to be the start of its own group. This is really very similar to the case of the smallest number, because 1 is exactly another number that has nothing before it. And the 2, which we know that in the answer it will also start a group, has something before it, but when we create a group starting with 1, then 2 will not have anything before it, and it will be the start of a new group. And that leads us to an idea for a solution to maintain the count of all the nums. And when is a number, after we have perhaps created some groups, when is a number a possible, or we are certain that it is the start of another group? Well, it has to appear, but the previous number, the previous value, cannot appear. And in that case, we are sure that this number is a start of a new group. So we will maintain all the starts of all the groups. So at first, those will be the numbers that satisfy this is start predicate. And in particular, the smallest number in the array will be in the list starts. We go through all the starts. In Python, of course, we can modify the list while iterating over it. That's useful. And if you come from, let's say, a C++ background, that may be quite surprising. But yeah, those iterators, just the list works by just always returning, by let's say generating all the new values. So when it gets modified, it doesn't invalidate all the iterators that were previously used. And of course, when we have a start already given, then we can just do the same thing as in the previous solution. Just we have to make sure that all the numbers that are necessary to be in the group, so start plus 1, start plus 2, appear, reduce their counts. And while we reduce their counts, we also see if they now become certainly a new start. And in that case, we add them to starts. And I do it backwards. So when I have a group, I know that we have a group of size 3 starting at 1. Then I go 3 to 1 and not 1 to 3, because otherwise I suppose that this check for what number becomes a new start will not work, because we want to first because in that case we could, for instance, remove a 1. We see that then we have a 2, and that 2 sees that before it there is no 1, so it is a new start. But then we remove that 2, so that would not work. Perhaps there are other ways to solve it, but the way of going backwards is probably the most intuitive. And of course, in both those problems, in both of those solutions, we have to at the end make sure that we used all the numbers. So either in the compressed representation that the numbers all appear 0 times, and in this case that no number remains with a positive count, so the total counts is 0.